Hello, everyone. Hey, I'm glad you guys are so energetic after the lunch. That was a good sign. So I'm Lucy Chen. I'm a senior software engineer in quality, working at Intuit.
And I'm Alfred Tan, senior DevOps manager with the development productivity group at Intuit.
So today we're going to talk about CI/CD with mocking and resiliency testing in AWS. So we'll take the questions at the end of the session. Intuit's culture is to simplify the business of life for our customers so that they can now imagine the way going back it was. We have several major key products, so raise your hand if anyone used TurboTax. OK, I see quite a few. So it significantly simplifies the way people file their taxes. So now you cannot imagine the way going back using paper and pen. We also have Mint, a personal finance software, which you can look at your personal finance overview in a one single glance on your mobile device. It's so easy to use. I use it all the time. For small business owners, we have QuickBooks Online. It allows you to look at your payroll, payment, bill, invoices, all in one single place. It simplifies the way people manage their business. We also have several other major key products for our accounting professionals. It's built into our DNA to look at how we can simplify the business of life. We also look internally how we can simplify the business of life for our engineers. And we're really excited to share this journey with you so that you can go back and also simplify the life for your engineers. If you're an architect, you're looking to onboard many different teams to continuous integration, continuous delivery. In AWS, we're going to talk about how we automate that. If you're looking to align many different teams for the AWS hosting strategy, the security requirement, since we automate all that, they'll be automatically aligned. If you're an engineer, you're looking to automate the AWS products, we're going to talk about how we use CloudFormation and Chef to do that. If you're an engineering manager, your developers are blocked because the dependency servers are not ready or because they're buggy. We're going to talk about how we use Wiremock to stop the dependency and unblock your team. If you're a QE engineer, your integration task failed because of the unreliable dependency server, not because it finds a bug in the system or test. We're going to talk about how we use Wiremock to fix that. If you're an engineer, you're looking to do resiliency testing, which was really hard to do before because we don't control the dependency server. We're going to talk about how we use Wiremock to do fault injection and do that easily. So now, let the journey begin. Let's talk about our first challenge, CI/CD in AWS, and Alfred is going to cover that.
All right, thanks, Lucy. So at Intuit, we take every precaution to protect all of our systems and our data. We have strict security requirements that we must adhere to in order to host any application or service in AWS. We're also required to use threat modeling in our architecture design to ensure we build security in from the very beginning. Any new service that we create must be onboarded into CI/CD. With our all-in strategy and moving to the AWS cloud, we have huge volume of services that needs to be migrated. Each of these services must have its CI/CD pipeline created. If we were to manually do this, it's going to be time-consuming, resource-intensive, and error-prone. And finally, any of the systems or services that we host must be highly available. So let's take a quick poll. Please raise your hand if you actually have similar requirements in the AWS. Good? That's what we're here to talk about. So to solve these challenges, we created Slingshot. So what is Slingshot? Slingshot is our internal tool that automates the hosting of our applications and services in AWS. We built security in. This means using industry best practices, tools, and principles used in software development, architecture, and security, and building that into our software and our infrastructure. Next, we automated the entire onboarding process into CI/CD. So all you really need to do is provide your code and your test. And finally, we built in HADR, high availability disaster recovery, into Slingshot. So this means actually hosting our application in multi-AZs, or availability zones. So let's walk through how we do CI/CD at Intuit and how we build security into our software development pipeline. Let's start with the build phase. So when code gets checked into the repository, we'll automatically build it and execute your unit tests. Then we'll run your code coverage to calculate how much of the code is actually being tested. Then we'll run your static code analysis tools like PMD and find bugs to identify inefficient code. Then we'll run your vulnerability scans with Fortify and Nexus Lifecycle so that we identify our basic software security is actually built into our code. So part of the CI phase, we're actually focusing on build and unit tests and providing quick feedback on the quality of the code that's flowing through our pipelines. So when our build promotions have passed, we'll automatically deploy that to our CI environment. This is basically your dev environment. We're starting to call our dev our CI since we wanted to extend the CI into this to include your deployments and your integration testing. So here we'll actually deploy your build artifacts and then your configuration files, and then run your basic acceptance tests, which are your BATs. What we're doing here is to ensure that your code is actually good enough for QA. So when BATs pass, we automatically deploy that to your QA environment. Here we'll actually execute your regression test. In addition, we actually do dynamic application scans with app scan. When regression tests pass, we'll promote that to your E2E, or end-to-end, and your perf environment in parallel. We'll run your E2E tests or your partner certification tests in your E2E environment, and your perf or load tests in your perf environment. Our promotional criteria here is it just needs to pass E2E. So when that passes, we deploy that to production. Here we'll do a quick smoke test, and then we'll actually do also your web app scanning with White Hat. So this is actually our continuous delivery and continuous deployment pipeline. With continuous delivery, we require all of our deployments to be fully automated. All the deployments should be consistent across all the environments. Promotions in the pre-prod environments are all automatic with triggered deployments into production. Our vision is actually continuous deployment, where deployments into production are all automatic and deployment approvals are built in. So let's walk through how we integrate CI/CD and security into Slingshot. Let's say you have a service that we're going to host with Slingshot. We will need to create an AWS account. What I'm going to do here is actually walk through from the bottom up. So our requirement is every single service that we host in AWS must have a minimum of 2 accounts. One for your pre-prod and one for your prod. In addition, each service account needs to be separate from other service accounts. The reason for that is to ensure that if an account is ever compromised, we limit the blast radius of the affected account. So next, we'll actually create your VPCs with your subnets and your security groups, and then hosted that in multiple availability zones. This is actually part of our AWS account setup. The automation here is actually provided by our public cloud consulting team. They are actually showcasing this here at reInvent. So we'll provide a little bit more details about that later. So be sure to check it out. So we build on top of this automation. So we'll automatically provision your GitHub repo. Here we'll provide your CloudFormation templates for your stack creation, your Chef cookbooks to set up your EC2 instances, and your Jenkins workflow engine for your CI/CD pipeline. Next, we'll create your CI/CD pipeline. Here, we provide your build automation using Maven, your deployment automation with Chef, your test automation with TestNG, and finally, your promotional criteria via Jenkins jobs. Next, we'll create your KMS keys for use for encryptions, your SSH keys for your EC2 instances. Then we'll create your S3 buckets, your egress proxy for your outbound connections, your bastion host, and finally, your Splunk forwarder. I'll go through a little bit more details in this in a bit. So this is actually part of our initial setup, and they're executed once per account. So let's see how this looks like when actually we execute the AWS account setup and the initial setup. So here we have your VPC account as part of the initial setup. We have multiple public subnets, your bastion host, your egress subnets, and your ELB subnets. We also create your private web, app, and database subnets. So part of the bastion host is we don't allow direct connections to our EC2 instances. For our egress proxy, we're actually using Squid to monitor all the logs of all our outbound traffic. So all your service logs from your web, app, and database are actually forwarded to the Splunk forwarder. This is then forwarded to our internal Splunk server, where it's actually scanned and monitored. In addition, we create your S3 buckets for your artifacts and your secret assets, your KMS keys for EBS and your secret assets. So let's build on top of this stack. So what that did was just getting your account ready to host your applications. So when you check in your code in your repository, we will automatically create your public-facing ELB and your private ELB. Next, we'll create your web and application auto-scaling group, and also your EBS volumes. So for the web tier, we currently support Nginx, and your app tier, we support Node.js and Tomcat. And if you have a database tier, we support RDS Oracle and MySQL. And finally, we create the DNS for your service. So you might just guess that this is actually part of our CI/CD process. And there are recurring events as changes flow through our pipelines. So let's take another quick poll. Who's doing CI/CD in AWS today? Good. What about CI/CD with blue-green deployment? Okay. So let's cover the initial setup. We talked about this earlier today, right? So you will have a pre-prod account and a prod account. Each of these accounts would have its own VPC. You have your public ELB subnets and your private web and app subnets. We talked about the CI/CD pipeline earlier. When the build promotion completes, we'll automatically deploy that to your CI environment. Here we'll create your Route 53, your public-facing ELB, your web auto-scaling group, your private ELB, and your app auto-scaling group. We will do a quick smoke test after we actually deploy your build artifacts and your configuration files. And then we'll actually update the DNS to point to this new stack. Then we will actually execute your basic acceptance test, which is your BATS. When BATS tests pass, we'll automatically deploy that to your QA stack, your QA environment. Here we'll create the same exact stack, do a quick smoke test, update Route 53, and then do your regression test. So we'll do this across all your entire pre-prod pipeline. When we're ready to deploy this to prod, we do that manual trigger that will automatically deploy this into prod, building the same exact stack. Do a quick smoke test, and then update Route 53. At this point, we're live in production. So the next time there's a change that goes through the system and it passes your build phase, we'll automatically create a similar stack. Let's call that the green stack. We'll deploy your build artifacts, do a quick smoke test, cut traffic to the green stack, and then destroy the blue stack. Then we run your basic acceptance test. So at this point, your green stack is actually live now in CI. One of the challenges with having blue-green is there's overhead in creating these stacks. It takes about maybe 15 minutes for us. So in this environment, we actually have an option to turn off blue-green. So all we do is deploy code that changes in your configuration files. So the only time that stack gets created, when you get your initial change, you get your blue, and the secondary change, you get your green. So let's say your batch test passed with green, and we'll automatically deploy that to the QA environment. Do the same thing. Smoke test, cut traffic, destroy the blue stack, and then run your regression tests. As you can see, most of our testing is not using the blue-green stack. All we're doing is do a quick smoke test. If it's good enough, we promote that stack over to your environment. The guts of your testing is still happening across your CI/CD pipeline. So now, when the green stack is complete, we deploy that into prod, do a quick smoke test, cut traffic over to the green stack. So in production, we're actually using weighted round robin for your Route 53. So this allows us to distribute the load between the two stacks. Let's say for some reason you have some issues with the green stack. We can quickly roll back to the blue stack, destroy the green stack. At this point, all we do is just wait for the next change to flow through the pipeline. Let's go to the other scenario where, let's say the green stack is good enough and we feel confident that we want to move forward. All we do is gradually increase the traffic to the green stack until we have 100% of traffic there. We drain your connections to the blue stack, make sure nothing's going through there, then we destroy your blue stack. All right, so let's see what are the key benefits of using Slingshot. So first, you get early feedback on the changes flowing through the system. You get that for free with CI/CD. With CI/CD, you increase the quality of the code flowing through the pipeline. With increased quality, you get more frequent releases into prod. And with this, we increase development productivity. So we could hire an engineer, give them a task to do, they check in their code. There's a big possibility that their change would be pushed to production from day one. We also automate the hosting of our applications. So if you have a new service, we'll automatically provision that for you. So Lucy, can you play the video? We'll do a quick video and see Slingshot in action. So here we have automated the onboarding process. So at Intuit, we actually have the service portal, where any services that we create has to go through this portal. This is actually created by a different team within Intuit. We liked it so much, we plugged Slingshot into it. So here, all it is just asking for your basic information regarding your service name, a brief description about your service, your acronym, and whatever icon you want to, whatever color you want for your icon. So as part of this is we'll also check to see what type of stacks you're going to build. You need Node, you need Tomcat, right? And then all these information is actually going to then kick off Slingshot in the background. So this demo will be focusing on the initial setup and how changes flows through our CI/CD pipeline. So here, we'll automatically provision your GitHub repo. You get your CloudFormation templates, your Shelf cookbooks, your Java ref app, and your Jenkins workflow engine. As part of the GitHub repo, we actually have your reference app in the app folder, your Jenkins workflow engine, your tests with your performance, and the core Slingshot in the platform. Next, we'll set up the rest of your AWS account. Here, we'll actually create your egress proxies and your Bastion host. These are all happening automatically after we actually onboard it through the portal. We'll set up your KMS keys for encryption. And then we'll integrate that into the CI/CD pipeline. So this is a view of Jenkins. Your pipelines are flowing from left to right. So they're currently on the first top, you have the yellow one. We have a CI build going on. The second line, you actually have a deployment to the QA environment. And then the third one, you got a deployment happening into E2E and perf in parallel. Everything in the yellow shows in progress. Blue is your to-do, and your green is your completion. So at this time, we're actually deploying to your CI environment at the top, and continue to kind of deploy for QA and into your perf environment. So when you see that completed, it's going to move on to the next phase. So at this point, it's actually deploying to your E2E and perf, and the perf just failed. So this is just as changes flows through our pipeline, this gets automatically triggered. So we do our deployment automation using CloudFormation and Chef. So this is what's happening in the background. So as part of blue-green, we talked about that stack. So here you actually have your ELBs created, your auto-scaling group for your web and app tier, right? So as new changes gets checked in, we create that new stack. Here you'll see some of the ELBs actually being created. So they're in progress right now. So now that's complete. And then the next thing we do is create your web and app auto-scaling groups. And that's also completed. So that's what's happening in the background. So can you switch back to the deck? So let's do a quick recap. So we talked about our challenges: strict security requirements, manually onboarding to CI/CD, and services needs to be highly available. Our solution to this is pretty much the same three things. First, automate. Second, automate. Third, automate. So we automated all the security requirements into Slingshot, CI/CD pipeline, and your header. So at this point, we're pretty happy with what we've created. So what can possibly go wrong?
Well, let's see what could go wrong. And thanks to your little concert out there, that was quite nice. So after the engineers checking a piece of code, it will be automatically built and deployed to the environment. The test will be run. If it passes, it will be promoted, auto-promoted to the next environment. So raise your hand if your integration test failed because of the unreliable dependency server. Okay, I see quite a few. We have the same problem. Our automation test failed because of the unreliable dependency server. It could be the dependency server is buggy, or they're not ready for integration, or simply because they're doing their own CI/CD update. But all this caused our automation test to fail, not because it finds a true bug in our system test, but because of the unreliable dependency server. That's not what we want. We're designed to test the system test. It shouldn't fail because of the external changes. When the test failed, the builds are not promoted. When the builds are not promoted, the code will not flow through the CI/CD pipeline. And essentially, we have a broken pipeline. This is a serious problem. We need to fix this. We need to make sure the test will only fail when it finds a true bug in the system under test. Our solution is to use Wiremock. Wiremock is an open source tool. We can stop the dependency. With that, we can fix our pipeline and make sure it will only stop when it finds a true bug, like it's meant to be. What is Wiremock? Wiremock is a library for stubbing and proxying web services. It can act like an HTTP server, which allows the system task or the automation task to connect to. It supports stubbing. Stubbing is essentially return canned responses. For example, if I give you request A, you will always give me response B. It will not go through any business logic. It's a profile injection. You can initiate a simple Wiremock API call and say, I want you to always return me some gibberish or an empty response, which allows the engineers to do resiliency testing, make sure our system on a task is resilient enough to handle all this. It can also simulate socket timeout and also inject delay. With this, now it's so easy to do resiliency testing. It was really hard to do before. It's easy to set up, a simple configuration change. It's easy to onboard, so your engineer don't need to dive into the code for the system on a task. They don't need to dive into the code for the dependency server. So all they need is a request and response between the system on a task and the dependency server. Then they can stub it. It's really simple. So how does it work? This is the flow before we have Wiremock. Your automation task will execute the actual task by calling the system on a task. Then it will talk to the dependency server. After you get back the response from the dependency server, it's going to construct appropriate response and flow back to automation task for validation. Our challenge, potentially your challenge too, is that when the dependency server is down or buggy, your automation tasks fail. So here's where we bring in Wiremock. We configure the Wiremock to be main in the middle. First, we deploy the Wiremock server. Then we point the Wiremock server to talk to dependency server. And then we point the system on a task to talk to the Wiremock. So the flow will look like this. Your automation task will set up the stub first by calling the Wiremock server. For request A, I want you to return me the stub, in this case, a blue smiley face. And then the automation task will execute the actual task by calling the system on a task. System on a task go to Wiremock and say, hey, I have this request A. What do you got? Wiremock will be like, OK, for request A, I have this stub, a blue smiley face. In this way, we increase our integration task pass rate because even if a dependency server is not ready or buggy, it's OK. We have our stub, and automation task will still pass. Because ultimately, we're trying to test the system on a task. It shouldn't fail because of the external changes. Another benefit is increased code coverage. So raise your hand if you spend a lot of time or even spend time to work with the dependency server team for the test data preparation. OK, I see a few of you. We all know it could be very time-consuming just talking to the dependency server team and find out and then coordinate all the test data set up. But with this, we can do that very easily. We can be self-sufficient. Let's say I don't want the blue smiley face anymore. I can simply initiate another Wiremock API call. Say, for request A, I want you to return me a new stub, a blue sun. And then, the next time the automation task execute the actual task, the SUT would talk to the Wiremock and say, hey, I have a request A. Wiremock will be like, OK, for request A, here's this new stub, a blue sun. Here we go. With this setup, we can make sure we can test different test data permutations. And we're self-sufficient. It's easy to do. Another benefit is that with the same setup, we can allow the other team to continue having the end-to-end experience. So let's say you want your automation task to always test against a stub. So only if the header matches Lucy's automation, then you will return the stub. There might be another team continue using your system on a task because their header doesn't have Lucy's automation. Wiremock is going to proxy it to the dependency server and just simply relay the response back. So flow will look like this. The SUT will go to the Wiremock and say, hey, I have this request C. Wiremock will be like, I don't have any stub for you. I'm just going to simply proxy it to the dependency server. In this case, with the same architecture, your automation task can continue to test against all the stuff you set up. The other team can continue to hit your system on task and have an end-to-end experience. So we achieve both things in one setup. And this is really, really powerful. So this is our architecture before we set up the Wiremock. It is important to understand this because it directly impacts how we set up Wiremock. We deploy our system and task onto 2 different EC2 instances in 2 different subnets, which means 2 different availability zones and 2 different physical locations. So let's say the SUT2, the data center, completely went down due to some unforeseeable circumstances, flash flood, earthquakes, whatever. We still have our SUT1 in a different subnet, in a different physical location, serving our customers. So the flow before Wiremock will look like this. The automation task will talk to the SUT load balancer. It could forward to SUT2, or it could forward to SUT1. We do not control that. The load balancer controls that. Let's say forward to SUT1, then it needs to talk to the dependency server. And after the SUT get back the response from dependency server, it's going to construct appropriate response and flow back to the automation task for validation. So our challenge, potentially your challenge, is that the dependency server is down or buggy. Then our task will fail. And that is not what we want. So here's where we bring in Wiremock. So we're thinking, we already have our SUT EC2 instances, we already have our load balancer. Why don't we just deploy Wiremock onto the EC2 instance? We save all the setup cost, all the effort. So the flow will look like this. Your automation task will set up the stub by calling the load balancer. Let's say it forward to SUT1 and set up the stub there, a blue smiley face. And then your automation task will execute the actual task by calling the SUT load balancer again. Let's say you forward to SUT2. Now the SUT needs to talk to the Wiremock. So it talks to the load balancer. The load balancer could forward to SUT1 or SUT2. Let's say forward to SUT2. Then you don't get the stub you just set up in SUT1. And that is not what we want. We need to make sure we always get consistent stub responses. Then what we realized that we need a dedicated Wiremock load balancer. We need a dedicated Wiremock EC2 instance so that we can get consistent stub responses. So the flow will look like this. The automation task will execute setting up the stub by calling the Wiremock load balancer. It's going to forward to the Wiremock EC2 instance and set up the stub successfully there. In this case, a blue smiley face. And then the automation task is going to execute the actual task by calling the SUT load balancer. Now the SUT needs to talk to the Wiremock. So it talks to the Wiremock load balancer and forward to the Wiremock EC2 instance. Because we have only one single dedicated Wiremock load balancer and one single dedicated Wiremock EC2 instance, we will always get the stub that we set up. And after the SUT get back the stub from the Wiremock, it's going to construct appropriate response and flow back to the automation task for validation. With this setup, we make sure we have consistent stub responses. And this is exactly what we need. We need to make sure our integration tasks will only fail when it finds a true bug in our system on the task. So let's look at the scenario without the stub. Let's say another team is using your system on the task. Wiremock is going to proxy the request to the dependency server. So the flow will look like this. The SUT will talk to the Wiremock and say, hey, I have a request C. Then Wiremock will be like, I don't have any stub for you. I'm going to simply proxy to dependency server. And after the SUT get back the response from the dependency server, it can construct a proper response and flow back to automation tasks for validation. So with the same architecture set up, you can test against the stub. You can also test without the stub. They can be simultaneously and don't interrupt with each other. And this is really, really cool. This is exactly what we need. We can run our tests against all the stuff, and the other team can continue to have an end-to-end experience. We can also put a flag in our automation test. If xmock equals true, we call the wiremock to set up the stub. If xmock equals to false, then we don't call the wiremock to set up the stub. So now I want to share with you some of the Wiremock code snippet to help you get started. This is a code to start up the Wiremock server. It's very simple, a one-line Java command. Java-jar, wiremock.jar, and use the verbose flag to turn on the logging. Then you specify the port you want to run, the dependency server you want to forward to. Now I want to share with you the Wiremock API to stop the response. Stub4 is the Wiremock API. Only if you get HTTP GET request, URL equals to from where. Then you return the stub with status code 200. Header, body, Taiwan. So this is so easy. You can just do it from your automation task. Now I want to share with you how I do the fault injection. Step 4, only if you get HTTP GET request, and only if your URL equals to something, then you return the fault message, an empty response. So with this simple API call, you can control to do the resiliency testing. You can make it return gibberish, empty responses with delays, and you can immediately initiate another call from your automation task to the system task and see if it's resilient enough to handle all this. It's so powerful and so easy to use, as you can see. What's the benefit of using Wiremock? It's just amazing. We fix our CI/CD pipeline. We make sure it will only fail when it finds a true bug in our system and test. And we don't spend engineers' time on unnecessary task failure debugging. We will focus the time on the really important things. Since we increase our code coverage, we have less production escapes and less firefighting. We have better code quality. So now I want to do a quick recap. The second challenge we're trying to solve is the integration task failed because of the unreliable dependency server, and it broke our CI/CD pipeline. And it's really hard to do resiliency testing. Our solution is to use Wiremock to stop the dependency and to do fault injection, so we can do the resiliency testing easily. So now we're thinking, we have this great tool, the CI/CD pipeline, Slingshot, and we have this great tool, Wiremock, to make sure that it will only fail or stop when it finds a bug in our system or task. Why don't we combine them so that every team that onboards to Slingshot will automatically get it? So now Alfred is going to cover Slingshot with Wiremock.
Thank you. So as Lucy talked about, we have this dependency server out there somewhere in AWS, maybe a data center. So here, we're going to provision a new service using Slingshot. This is part of your initial setup that we talked about earlier. We create a new service, system under test. So what we initially did was actually have your app servers connect directly to your dependency server through the internet gateway. So we know the problem with this, right? So when the dependency server is not available, your tests for your system under test fails. So all we really did was actually create a new Wiremock stack. Create your Route 53, your public-facing ELB, your Wiremock auto-scaling group. And we just wired it through the Wiremock to get to your dependency server. So what this does is when the dependency server is not available, your test continues to work. You see?
So now we have Wiremock with Slingshot. We're thinking, how can we make our engineers' life even simpler? How do we simplify the life for them? How do we automate the Wiremock deployment? So there are 2 steps. The first step is to do the stack creation in AWS. The second step is to automate the Wiremock deployment. Now let's talk about the Wiremock deployment first. We chose to use Chef. It's an infrastructure automation tool. You can call how you deploy and how you manage your infrastructure. It supports version control, and we can share the code between the teams. So we wrote a Wiremock recipe to do the following things. First, it's going to download the Wiremock jar onto our EC2 instance. And then it's going to start the Wiremock server with a Java one-line command that I just showed you guys. It's very straightforward. We also use Berkshelf. It's a dependency manager for Chef to grab the dependency that we need. First, it's going to get the Java recipe to download Java. And then it's going to get the Wiremock recipe to download Wiremock and deploy the Wiremock server. So now to show you through some of the Chef code snippet. So this piece of code will start the Wiremock server. And we try to parameterize it as much as possible so that we can reuse this piece of code with different teams and also different environments. So you can see we cd into the directory, and then we call the Java jar command, and we parameterize the port, the proxy information, and the dependency server information. Now let's talk about how we automate the stack creation. We chose to use CloudFormation. We use it to provision the EC2 instances, the ELB, created the auto-scaling group, security policy, AM roles, and etc. So now we have our AWS CloudFormation to create the stack. We need to call the Chef to deploy the Wiremock. So decided to call Chef from CloudFormation. How do we do that? So inside the CloudFormation, there's a section called Instant Launch Config, where you can write the shell script. So we wrote the shell script to first download and install Chef. And then we're going to run Chef. In this case, we created a Wiremock role to execute the Java recipe to download Java, and execute Wiremock recipe to download Wiremock, and then start up the Wiremock server. So this is the code to call the Chef from CloudFormation. So you can see we're executing Chef solo, and then we execute the role. It's referencing to the Wiremock role I just talked about. And then we're passing environment-specific variables so that this piece of code can be reused for different environments and also different teams. So the benefits of having Wiremock and Slingshot together is just tremendous. We have a simplified CI/CD pipeline onboarding. All the Jenkins jobs are automatically created. We make sure it will only fail when it finds a true bug in the system under test. We have our resiliency testing capability built in. So every piece of code you check in, you make sure it's as resilient as before. We have our security features built in. So we make sure we're always meeting the highest security requirements for our customers, and we're always serving the safest software for our customers. So now I want to do a demo. I wrote a simple sample app, SUT. It's going to call the Yelp API to get the business detail of a restaurant. Instead of calling Yelp, I configured it to talk to Wiremock. And then my automation task will call the Wiremock to set up the stub. And then it's going to call the SUT to validate it can handle it properly. So you can see the endpoint I wrote is lunch. And then the first step it's going to do is call the Wiremock server instead of the dependency server, instead of Yelp. The second part it's going to do is construct response according to the response it gets back from Wiremock. So you can see initially it's supposed to talk to Yelp, but I configure it to talk to Wiremock instead, so that we can stop the dependency. And then after we get back the response from Wiremock, we're going to check if it's a successful response or not. If a status code equals to 200, we're going to parse the response into a hash map. And then we extract the ID out of the response and put it into a JSON object. After that, we return a status response with 200 status code and the JSON object we created. So call the Wiremock, get the response, get the ID, and return the response with the ID. If we don't get a 200 status code, we're going to put in an error message in our JSON object. And then we will return the response with 500 status code and the JSON object with the error message. So very straightforward. If it's success, return 200 with the ID from the Wiremock. If not, return a JSON with the error message and a 500 status code. So let's look at my automation test. My automation task is going to call the Wiremock first to stop the response. And then it's going to call the SUT to validate that it's handled it properly. It's actually getting the stub. So similarly, it's going to call the stub4 API only if it's a HTTP GET request and URL equals to V2 business Taiwan Cafe Milpitas 2, which is a great restaurant, by the way. Then we will return the stub with status code 200 and with a body as specified in a file. So the file, in this case, is temp.json. Now let's take a look at temp.json. So instead of Taiwan Cafe, I change it to Lucy. So with similar setup, you can test different test data permutation. So now my automation task is going to call the SUT endpoint, web app Lucy SUT launch. And it's going to validate returns a 200 status code and the ID, Lucy, instead of Taiwan Cafe. So now let's run it. So you can see I'm hitting the system and task endpoint, web app Lucy SUT launch. And we got back the ID, Lucy. So with this, it's very easy to test different test data permutation. And it's really powerful. You save all the time to talk to a dependency server team. You can do all this by yourself with a simple API call. Now I want to share with you guys how I do the fault injection. So first, you call the Wiremock API to do fault injection. And then you call the SUT to make sure it's resilient enough to handle this. So it's the same endpoint, stub4, get request, and the endpoint is the same, V2 business Taiwan Cafe Milpitas 2. Then it's going to return some gibberish, mail phone response chunk. And then we're calling the send endpoint, web app Lucy SUT launch, and we validate that it's getting back a 500, and with the error message. Now let's run it. So you can see I'm hitting the send endpoint. Web app Lucy SUT launch, and then I validate, we get back a proper error message. So it's very straightforward, very simple, and very powerful. So now I want to do a quick recap. With the combined solution of Slingshot and Wiremock, it's just tremendous. We have a simple CI/CD pipeline onboarding, and our builds are automatically promoted with a task pass. We spend less engineers' time on unnecessary debugging, and we found a resiliency issue before the production. We have better customer experience. And we're happy engineers. Most of things are automated. You have spent less time in the debugging. You spend less time in production firefighting. How can they not be happy? I'm happy. What we learned. So the initial investment of learning the new technology takes time. CloudFormation, Chef, Wiremock, but it's definitely worth it. Once you learn that and automate everything, it's fast and easy to maintain. So definitely recommend it. Try to be flexible in your code so that every team can reuse them and can reuse in different environments. Make sure you set up your DNS name because we use blue-green deployment. With the DNS, then you don't need to change your endpoint. So here are some of the references for you guys to go back and look at it. So this is a paper I wrote for Pacific Northwest Software Quality Conference. This is the Wiremock link, the Chef link, and the CloudFormation link to help you get started. So here's another related session hosted by Intuit that's going to be very helpful to you guys. This is talking about AWS account creation automation. This is going to be really cool. It's ARC 344. It's hosted tomorrow at 2:45 p.m. Make sure you check it out. And here's a contact for me and Alfred. So feel free to reach out to us if you have any questions. Thank you, and make sure you complete the evaluation.